the signal layer. Okay, so signal layer is the lowest layer of the verification environment. Okay, so what all the features, how to implement the signal layer with the help of system Verilog, we'll see in this presentation. So this layer provides a signal level connectivity to the DUT. So here you can connect the DUT with the help, like with the modules. You know that we will write a module, we'll write a BFM and we'll connect that BFM in the top. That is one way, usual way, where that will do in the Verilog. The signal layer provide pin name abstraction to enable verification component to be used unmodified with different DUTs or different implementation model of the same DUT. So for example, the RTL description of the DUT using interface constructs and the gate level description of the same DUT using individual bit input output signal. So what they are trying to say is, so when you are writing like when you are implementing interfaces with the help of system Verilog, what is the use of that? Okay, suppose in future you need to add a signal. Okay, so in that case you just open a file, interface file, and you add a signal in that. Okay, so after adding the signal in the interface file, what you have to do, you have to just perform the connections. No need to modify each and every module. Suppose you are adding a module, suppose you are adding a signal inside a module, so in that case you have to change the module. After that you have to change the top, like that you have to perform many things. In interface, just add that module, automatically your module will work. So that is what the abstraction they are trying to say is. So this layer may also abstract synchronization and timing of the synchronous signal with respect to the reference signal. So the second responsibility of the signal layer is, now here you have to take care of timing and synchronization. Okay, because what is your objective? The objective of the signal layer is to take the transaction as an input from the higher layers of the verification environment and convert that transaction into pin level signal description. Okay, so when you are applying that values, when you are applying that values to the DUT, so during that time those should be synchronous, and you should maintain the timing. Timing means when you are forcing the values, you should force with respect to some reference signal. Okay, so that is what they are trying to say. Now the signal abstraction provided by this layer is accessible and may be used by all the layers and test case above it if the single level if the single level access is required. Okay, so this is the abstraction level, like you are writing a task and you are converting that task into, means you are passing the value of this task to the signal level interface. Like, so abstraction, here only you have to perform the abstraction so that your test case should able to access each and every pin of your DUT. However, verification environment and test cases should be implemented in terms of highest possible level services provided by the lower layers and avoid accessing signal directly unless absolutely necessary. You take example, you see here we have implemented the layer test bench. Okay, your test case we know that our test case can access each and every corner of verification environment as well as DUT. Okay, so this test case can also access the physical signals. Okay, but our objective is to hide the complexity. Okay, but there are certain scenarios where we have to come down to the pin level and we have to verify the DUTs. Okay, so that is what they are